Welcome to today's webinar, Unleashing the Economic and Sustainability Power of Existing Buildings, hosted by the Maryland Department of Planning on behalf of the Smart Growth Information Clearinghouse. My name is Michael Bayer. I am the Manager of Infrastructure and Development at the Maryland Department of Planning and Project Manager for the Smart Growth Information Clearinghouse. The Smart Growth Information Clearinghouse is a project of the Smart Growth Network, supported by the U.S. EPA's Office of Community Revitalization and managed by the Maryland Department of Planning. In addition to hosting webinars, the Smart Growth Information Clearinghouse has a website, smartgrowth.org, that provides current information on effective growth, development, and preservation practices. The website provides news and information about events, funding opportunities, awards, and resources to help local decision makers foster healthy, resilient, and economically vibrant communities. The Clearinghouse is also the virtual home of the Smart Growth Network, a nationally recognized coalition of leadership organizations that have formally endorsed the principles of smart growth. This webinar is one in a series of webinars produced by the Maryland Department of Planning on smart growth and planning topics available for viewing at smartgrowth.org. We are recording this webinar and will post it on our website early next week under the Webinar Archives tab. In fact, it may be sooner than that, given our circumstances. We encourage you to visit the website and subscribe to our e-newsletter to get smart growth news and information and to learn about our upcoming webinars. You can also learn about planning initiatives, planning tools, and educational opportunities in Maryland by visiting the Maryland Department of Planning's website at planning.maryland.gov. Viewers of this live event are eligible to receive 1.5 CM credits from the American Planning Association and 1.5 CNUA CEU self-reported credits from the Congress for the New Urbanism. To log your AICP credits, visit the American Planning Association's website at planning.org, log into your account, and search for the name of today's event, which is Unleashing the Economic and Sustainability Power of Existing Buildings. You can also search for event number 919-8822. I'd also like to acknowledge our partner today, Island Press, and their partnerships manager, Jen Hawes. Founded in 1984, Island Press's mission is to provide the best ideas and information to those seeking to understand and protect the environment and to create solutions to its complex problems. Participants of today's webinar are eligible for a discount on books in the Island Press catalog by visiting islandpress.org and using the code WEBINAR. So to get started, our speakers today are Craig Stevenson and Beth Eckenrode. Craig Stevenson is president of AUROS Group, a technology company based in Pittsburgh. Craig is credentialed in virtually all known building performance standards. He is known for his role in establishing Pittsburgh as a leader in evidence-based performance for the built environment. Evidence-based performance uses technology to bridge the gap between hoping a building is performing as designed to knowing a building is meeting its performance goals. Craig sits on the North American Passive House Network Board of Directors. He is a founding member and vice president of the Passive House Western Pennsylvania organization and also sits on the City of Pittsburgh's Clean Tech Roundtable and the P4 Performance Measures Committee. Craig is also a committee member with the AIA Plus 2030 Committee on the Environment. Beth Eckenrode co-founded AUROS Group in 2016 and is currently its board chair. She has successfully built and developed high-performance businesses and teams as an executive, a consultant, and as an entrepreneur. Beth is accomplished in the fields of strategy, general management, marketing, business development, executive coaching, training, facilitation, and conflict resolution. Beth is certified as a Reset AP with regenerative, ecological, social, and economic targets, a Fitwel ambassador with Centers for Active Design, a Fitwel certification program, and is a strategic advisor to the North American Passive House Network. She is a member of the Urban Land Institute and the Pittsburgh-based Green Building Alliance. Following the presentations, Beth and Craig will answer as many questions as time permits. You can submit a question at any time during their presentations by using the questions tool in the control panel located on the right side of your screen. So with that, I'm going to turn it over to Beth. Welcome, Beth.
Great. Thanks, Michael. I appreciate the introduction. And thank you, everyone, for joining us for a discussion on existing buildings and the power they possess. Now, risking the obvious, as we get started, I'm going to lay out a couple of points that most people might know, but put together might bring a different level of understanding to the importance of this discussion today. To keep global warming to less than 1.5 degrees C, we have to reduce greenhouse gas emissions about 30% by 2025. More than 90% of 2025 building stock already exists. And our greatest point of leverage to move the greenhouse gas needle is existing buildings. So that's our environmental motive for the conversation today. Our financial motive is that buildings consume 40 to 50% of all energy. And our social motive is that the relationship between buildings and occupants is becoming clearer every day. Research and evidence shows the impact air, lighting, and sound have on wellness and occupant performance. But here's the problem. Building owners struggle to prioritize and invest holistically in existing buildings to achieve sustainability goals. And when we're talking about sustainability, we're talking about everything related to energy, carbon, and all elements of indoor air quality.
So hi everybody, this is Craig. After spending about 25 years in the construction industry, we've seen owners struggle with how to deal with their existing building stock. When you're triggered with the life cycle trigger of systems failing, a deferred maintenance trigger, a natural renovations trigger, most of the time owners are just looking to solve that specific problem and not think holistically about their buildings. But we'll show you in a few how to think about that more holistically and how to look for whole building solutions as opposed to small incremental interventions.
Right, so when we talk about building performance, we like to use the term connected. And connected means looking at an existing building holistically, like a system. To do that physically, to look at a building physically in a holistic way, we use building science. To do that digitally and look at a building holistically from a digital platform, we use technology. So today we're going to highlight what we consider to be key foundational elements to delivering performance, not just in design, but all the way through to operations. In November, we published the book, The Power of Existing Buildings, in collaboration with Dr. Robert Schroef of Duquesne University. It's a map for owners of existing buildings to see the full picture of how to reduce the risks of investing and increase the likelihood of achieving meaningful building performance goals. So when we look at those three areas of performance and financial and social motives, we answer a few questions. Did I get in operations the goals I set in design? Did I get what I paid for? Is our financial question. And is my building positively contributing to occupant health and performance? That's back to our social motive. And that's a really interesting question today, isn't it, with the backdrop of COVID-19 and the struggle that many schools have in various regions of our country, creating healthy environments for students to live and learn. So we have a couple polling questions for you today, and here's the first one. Related to building performance, which of the following do you spend the most time considering? So there are a lot of areas in the world of sustainability, and what we'd like to understand is how you feel about the time you spend in each of these areas. And I believe the poll is open. Can you see the answers?
Okay.
So as we move forward then through the presentation, we're going to move from theory into practice. And when we start on the far left side with goals, we're going to spend a fair amount of time on goals, to the point where you might wonder, well, why do they spend so much time on goals? It's fundamental. And it's not just goals from the standpoint of, what certification do we want to get? Or what boxes do we want to check? It's what do we want to measure in operation? So when you go all the way to the right-hand side, it's about measuring performance. So when we get on a project with an owner, the first question we ask is what constitutes success? So what do you plan to measure in operations? These questions force owners to delineate between items on a list for checkoff and versus what matters to them environmentally, financially, and socially.
Michael, do you have the results of the poll for us?
Yes, we do. So the response here was 48% energy cost, 41% health and well-being, and 11% carbon emissions.
That's really helpful. And pretty much what we would expect, especially with the current environment. Usually those health and wellness numbers would be a little bit lower, but people are starting to ask the questions of relationship between buildings and occupants, whether it's homes, businesses, churches, schools. What's the relationship between buildings and occupants from a health and wellness standpoint? So that makes perfect sense. What's coming is more and more a conversation around carbon. But for now, as we go through these goals and as we go through our presentation on the power of existing buildings, we encompass all of those. So whether it's energy or it's carbon, whether it's cost or occupant benefit, we're going to get at all of that. So we want to jump ahead. I want to tell you where we're going to end up. We're going to end up at this slide right here once we get towards the end of our presentation, but I wanted to pull it forward because we're going to talk a little bit about a dashboard. And what's unique in how effective a dashboard is context. So to answer the questions, did I get what I paid for? Or did I get in operations what I goaled for in design? We need a different kind of context. We can't simply look at how a building is performing against itself over time. We have to compare a building against expectations. So how do we define expectations? Well, they've shifted over time, right? If we go way back and we look into like the 1960s where activism was everything, expectations were all around conservation and increasing awareness, establishing people's mindset around what might be possible in the world of conservation and activism. That translated into general prescriptive standards, where you had a list of things you had to accomplish. And if you accomplished those list of things, your building was green. Then expectations shifted to performance. It's not enough to check boxes. We have to know what certifications are going to drive actual building performance. And the move from general prescriptive standards to performance was all about building science. Then we went from performance into now where we are today, which is accountability. So whether you have climate change acts in your area or energy disclosure ordinances or stretch codes, even legislation like New York City put in place last year, the accountability is shifting the burden of proof today to building owners. The benefit of technology, though, is that it makes it easier to automate reporting in the forms of accountability that are expected by governing bodies today. So now that we understand the requirements and that they're on or soon to be on building owners, so what requirements do they have today? We start on the fundamental pieces of our map to move from theory into practice, and that starts with goals. And the reason we start with goals is this picture. We love this picture, right? So our approach is essential to the way we think about alignment. But if you look at the picture on the left, teams talk integration, but it often looks and feels like spaghetti noodles on the left. Goals, specifically metrics, helps teams align, not only on their intentions, but align their work, and most importantly, align on results. And this is a very iterative process. Craig will talk about this a little bit more going forward. Another foundational element for us when renovating existing buildings is how to best use technology. We're going to talk about technology in a couple different ways, but the primary two pieces of technology that we're going to talk with you about today are building modeling or simulation, what you may have heard about lately in terms of digital twins. We're going to talk a little bit about that, and then we're going to talk about integrated performance dashboard, which is what I showed you a couple of slides ago, and it's where we're going to end up. But first, before we do that, Craig, maybe you could give a little bit of history on modeling and where it's come from.
Thanks, Beth. So most people who practice in construction are very familiar with BIM, building information modeling. And when we talk about technology, I think it's helpful for us really to kind of break it down and explain what we mean by technology. So building information modeling has been around for a while now. And in the early days of building information modeling, architects used to do their 30-dimensional modeling, and they would keep it and call it IP and not be able to distribute it. They were worried about liability and other reasons why it was just never really shared. And then fast forward to today, over the last couple years, we're seeing this reinvention of BIM, where we're using it for clash reporting, we're using it for for facility management programs, we're using it to inventory systems and start to help us identify when a piece of equipment goes down. All the information is then recorded in the building information model. That's technology, right? And now it's starting to be shared through building BIM execution plans. Well, what we use is we use building energy modeling. And today, building energy modeling is where BIM was about 10 years ago. You know, we hire someone on our project teams to do some modeling, and they give us some paper reports. We never see the model, we never challenge the assumptions, and it's really a closed process. And we think that that's really not where the puck is going, so to speak. That's not where the whole macro trends in the industry are moving. If you have aspirations in a project, you want to use a building energy model in a collaborative way, meaning an open model, one model. We don't no longer get paper reports, we get the actual model with support from backup information. And the interoperability between BIM now and BEM really makes it easy to bring up an energy model very quickly, and then run it through calibrations if we have data for calibrations, and then get a model that we can really start to use to do testing and do our what if scenarios. So that's one side of the technology, the repurposing of an energy model. What does that take? How do we do it? What's it look like? The other side of the technology is smart building infrastructure. So most people are aware of the advent in meters and sensors and the cost dropping, and everybody wants the new toy in their building. And they're really racing to get those, but without having a connection between why are we measuring this and how are we getting this solved in design, it becomes difficult for project teams to make the connection. So what we are going to show is how do we take high performance building through building energy modeling and merge it with smart building technology, and what should the two look like together, and how do they collaborate to produce the highest performing building possible for our clients moving forward for the life of the building. So that's how we define technology. And what that looks like, getting back to this concept of integration and alignment, right? When we talk about setting goals, we're not talking about setting goals in terms of hanging a plaque or, you know, theoretical goals. We're talking about metrics. So if we're setting goals for energy, for example, those can be measured in the simulation. They can be measured in the smart building infrastructure. Same with indoor air quality. We can measure parameters of indoor air quality like CO2, temperature, humidity, particulate matter in a building, VOC, volatile organic compounds, and we can start to measure whether or not we are managing them in our buildings, right? So when we set goals, we'll talk about how do we do that using evidence-based criteria. How do we take that information and then use it in a simulation to come to a design solution that meets those goals? And those goals may change over a period of time. That's just common nature for the business we're in. You know, we have constraints relative to budgets, schedules, complexities of projects, and we need to be able to be flexible in how we address our goals and how we change them. But the simulation environment is still the same. It should be collaborative, it should be open, it should be an environment that everyone can access. That is really where the integration begins and ends from our perspective. And then measure performance. So your smart building infrastructure, we have to build case studies around our meters and sensors to connect our goals to the operations in a building. So this brings us to our next poll question, and we'll put that up on the screen. The question is, does your organization have stated building performance goals? So this is organizationally. So think about the clients that you may be working for or the businesses that you currently work for. Are those goals set in corporate sustainable reports that, you know, are theoretical and really not implementable? Or are those goals actually something that we're actually practicing in the field?
And given in the first polling question, you know, the results were split between the things you consider and spend time thinking about is energy and health and wellness. For those of you who whose organizations have building performance goals, how do those compare to those numbers? Do you know those energy goals and those health and wellness or health and well-being goals?
I see the poll is closed. Michael, do we have results?
Yes, so there's actually a pretty exact split between no and not sure at 33% each, and then 17% each for yes and I know what they are, and yes, but I don't know what they are.
Oh, that's interesting. So a third yes, a third no, and a third not sure. And of the third that are yes, half are know what they are and half don't. So super interesting. But given the first polling question around, you know, just a climate conversation in terms of what the organization stands for, you know, the fact that you spend a fair amount of time considering energy and health and wellness, and in some cases carbon, it's a good conversation to have in terms of, you know, what are our building goals? What are we trying to achieve? You can't necessarily make progress on something until you have a goal set. So we would encourage that.
So those numbers are actually pretty telling, because this is pretty consistent with what we see when we practice, is that, you know, third or less than a third really know what their goals are. And think about that. You know, we're the ones being challenged with facility management. We're the ones being challenged with intervention into existing buildings or even construction of new buildings. If we don't know what our goals are, then where are we going? You know, chances are we're racing back to code, and we're racing back to building buildings like we've always done, you know, business as usual. And that's not going to necessarily get us where we need to go. So it's not an unusual answer, and it's, I think, quite telling. So when we talk about goals, you know, I've always said that we talk about energy or evidence-based performance goals first and programs second. So to the right here, you'll see the common sustainability programs that we see in the United States. We are certified and we practice in every one of these. And when our clients come to us and say, we want to do a LEED building or we want to do a well building, our first question to them is why? What are we getting at? Are you guys a school and you're concerned about CO2 because you want to be able to take tests in an alert mode? Are we a hospital? We have immunocompromised patients that need particulate matter levels that need to be at certain areas. Why do we care about those programs that we're selecting? Are we doing it because we're mandated to do it? But if we want to get at what do we want from the building and how we extract occupant value from that better building, then we need to start with the evidence-based side of this. And you'll see all the goals that we listed here, and we'll get deeper into this here in a few slides.
So maybe you could give a quick example, Craig, of where we started out with just the metrics and the goals and ended up with a program unbeknownst to us.
Yeah, great point. So we had a project in West Virginia. It was a sports complex, rather large. They had 3 soccer fields and 8 basketball courts under roof with other amenities. And because it's an athletic facility, they wanted to make sure that they had a really solid building in terms of a healthy indoor environment and air quality. So when we started with them, we worked to tighten up the building. We made the thermal barrier better, focusing on thermal comfort for the most part. And because we had a tight building, naturally, we can control our infiltration and exfiltration of outside air. And if we can do that, we can stick it through filters. So now all of a sudden, you're seeing this natural order of sustainability of how we control environments in a building. Once we did that work and we worked closely with the architect and the subconsultants in the engineering trades, we started to build the building. About 80% of the way through it, the owner really learned about well through just other processes and decided, you know, this building is set up for it and we want to try it. So we ran through a checklist under well, and we ended up performing at a gold level. And now we're implementing well for that project. And the lesson learned here is that if we proceed with evidence-based goals, the programs will follow. If we go with the programs first without evidence-based goals, we may not be aligned to what we want to get out of these buildings. And there's a running joke in our industry, I'm putting another bike rack up to get another plaque. We're not aligned, right? So we want to make sure that we spend our money in the most advantageous way possible to build the best building we can for those occupants. If it results in a plaque, great. If it doesn't, then we want to at least ensure that we have a high performance building as the owner deems. So when we talk about goals, I want to be specific on what are we talking about. So typically when we build an owner's project requirements report, an OPR as it's commonly known, we try to keep it to 1 to 2 pages. We've seen OPRs that are 25 and 30 pages deep with a lot of theory and why I want to do this. Those don't get read. Project teams aren't reading them. They look at them one time, they put them under their desk, never to be seen again. If we can keep an OPR to a 1 or 2 page document, then all of a sudden it becomes a tool that lives with the project for the life of the project and even through operations, because these may change. It's an existing building. We may have thermal bridges that we haven't really dealt with, and once design showed us that constraint, now we have to deal with it differently. So our energy goals may change, our air quality goals may change a little bit, but if we have a working OPR, now all of a sudden we can have a living document that we balance our goals versus our costs and the complexities of a project. I think it's also worth mentioning here on our OPR that we're showing some common things around energy and IAQ, indoor air quality. What's missing here, and glaringly missing, is water. Potable water in terms of consumption, stormwater in terms of zero offsite, materials, embodied energy. So there's a lot more into a really quality OPR than what I'm showing you, but I just wanted to make an example that we can get to metrics on this stuff pretty easily, and those metrics will be the common thread through any programs you may pursue. So we get back to this idea of integration. You know, where does integration and alignment meet? For the purposes of really what we talk about and what we do, it meets at the model, right? That's the common source of truth. There is no argument about loads anymore because everybody's in an open model. The architect is defining the envelope, the thermal barrier and your air barrier. The architect is defining fenestration for your windows. The owner's coming in and talking about schedules and people and how many people and when they come and go. The mechanical engineers are talking about systems, HVAC, and the electrics are talking about lights and networks and things like that. So again, everybody likes to revert back to their silo. And what we see typically is we'll get into a project, we'll run a great charrette at the beginning of the project. Everybody leaves all pumped up and everything's great. We read a report and everybody's aligned. 2 months later, you know, we're getting into the dog days of design and we're in early DD, and budget constraints are starting to pop up, schedules constraints are popping up, and most people revert back to what they know, right? We go back to business as usual because I can go fast and I can deliver a product that I've done for the last 15 years. If we're going to do aspirational projects and figure out how to transform buildings, there has to be a realignment. As building owners, advocates, as lead architects, you'll feel it, you'll know it, you'll see it. As soon as the team starts to have different conversation, they start to flip back to their silos, that's a real big red flag for it's time for a realignment. And again, that realignment might not get back to the goals you originally established, but it'll at least get back to a goal conversation, which is really where you want to be. So this is going to be a discussion here about simulation. This is where everything happens in high performance building planning and delivery. So traditionally, when we do modeling, we've always been asked to come in at the end of schematic development or at the end of design development or at the end of contract, at the end of the major definable features of architecture delivery, right? And they get to the end and they say, okay, model this and tell me where we're at. Same thing with estimating. They give it to the estimator. Tell us what our number is. Well, if you're at the end of the SD and you missed your goals through the simulation, or you missed the number on the estimate, then that architect has to go back and redesign. That's costly. It takes time. Nobody likes it. Everybody's angry. That's the wrong way to do it. Traditionally, it's the wrong way to go back and check something. The best way to do it, in our opinion, is you bring the model up first. So in early schematic development, we are doing things like massing and orientation. We're doing things like window to wall ratios. Those are for new projects. For existing ones, we're doing a lot of calibration. We're looking for those constraints of thermal bridging where I can't really get rid of a thermal bridge because the deck goes out and touches the clad, but I can mitigate it. So we're doing a lot of that early analysis in early SD. We're doing cost analysis with it at the same time. Now, when the architect puts pen to paper and they're figuring out what their wall optimization is, they're doing it with the benefit of being informed by the model and the estimate, not the other way around. Now the architects can move very fast. They can talk about loads. They can have the answers before they actually put pen to paper and design this. This is what needs to be done to get to a high performance building. And this doesn't just stop at SD. SD is the early stuff. So think about like a funnel. You're doing the really big stuff early in early SD. And as you start moving forward, you lock in your wall optimizations, you start locking in your loads. Now all of a sudden we're looking at systems by late SD, early DD, and then you start refining. Right now I'm tuning windows, I'm looking for tuning systems and heat recovery and things like that as we go through DD and into CD. And by the time you're in CD, then you're into the minor refinement. That's normally how continuous modeling and continuous estimating have to work together. We can't design it and then figure out how to fix it afterwards. That is inefficient, it wastes time, and it wastes money. So this is an example of a project. It is an existing building for the most part, with a large addition on top and a large addition to the side of it. This project was brought up in conceptual. Sorry. So this project was brought up in conceptual. We had early massings, and we started talking about, with the addition, what does that the fabric of the envelope look like? How can we start making that connectivity between the addition and the new building and eliminate our thermal bridging? These are all conversations that were happening in early SD, is right where it should happen. By the time we started finalizing the geometry and the fabric of the building and our wall optimizations and our elimination of thermal bridging and our balancing of window to wall ratios and our balancing of tuning windows, now all of a sudden, by the time the architects roll up their sleeves and start putting pen to paper, they know where they're going. This is how it's done. This model was shared with the architect, the owner, and the MEP engineers so that they can lean in very early and start doing what if scenarios around what they were doing. This is a project we never had an argument about a load conversation, which commonly happens in traditional construction. The architects will want to do better windows, so they go ahead and spec them, and they spend a little more money to get them. And then they go and have a conversation with the mechanical engineer who refuses to change the specifications on the loads. And the architects are like, well, wait a second, I just put all these great windows in there. How do my loads not change? The answer to that is in risk. The MEP puts the stamp on the drawing, and they're not willing to take a risk that the architects are going to build a better envelope. So when we do it early, we're talking not just about using simulation to get to the solution, but we're also talking about how do we build in the right quality control, quality assurance testing so that we can start to not just design it, but build it in a way that the mechanical engineers will trust, and then they'll reduce the loads. And then when we get to operations, we want to keep reinforming that model so that we have it for the life of the building. And I'll show you why in a few minutes.
And so if you think about this specifically to an existing building, the challenge with an existing building is understanding what the theoretical optimum performance level of that building is. So you start to change the way you think about a building and its potential when you have a simulated version of how that building could potentially improve or perform if you invested in it. And so once we do that work and we build that model and we begin to simulate, and all the team members lean in and everybody's working towards the same common goals and the same agenda, you realize how quickly you can and how affordably you can get to improving the overall performance of that building. Everybody becomes aligned. The other thing to note is the way we do this is we think about modeling and we think about the simulation, the digital twin of the building as an asset that lives with the life of the building. So it's part of that building's future forever. Anybody comes into that building and touches it again, it has the benefits of understanding what the building was designed and invested in to do and perform.
Right, and then as an existing building, there's an opportunity to bring our measurement verification system in early to the building, not just to give us the operational answers, are we getting what we paid for, but also because that information becomes calibration for the model. I'll elaborate on that in a second when we get into the technology side for the measurement verification. So we talked about continuous estimating, and as someone who spent the better part of my career as an estimator, I just wanted to talk briefly about the differences in estimates and how to make sure that when you begin the project, you have the right estimator with the right estimates for the project. So there are a lot of times where people square foot. You could square foot the whole building, call it $200 and kind of get there. It doesn't give you the ability to really use an iterative estimate in early SD when you're talking about wall optimizations, right? So we can also see square footages for trades. So like HVAC, $25 a square foot, or electric at $16 a square foot. Again, it doesn't give us that granularity to start trade-offs. So when we do this, I'm stressing to people that we talk to in this industry that want to do high performance buildings is that you need to get either a contractor on board early if your appetite for integrated project delivery is such, or find a third-party estimator who understands how to do detailed unit price cost estimates. This is an example. So what you're seeing here is 3-inch batts insulation. It's one line item in Division 07 thermal barrier. You're seeing the quantifications, you see the unit price for materials, and then you can see the production on that all the way through the total price. If there's an equipment, you'll see that as a unit price as well. And the value here now all of a sudden is that when I'm talking about that thermal barrier and I'm doing envelope optimizations, now all of a sudden I can see the difference between batts, blown in, mineral wool, spray. So when I'm creating that envelope optimization and making sure my envelope is perfect from a building science perspective, I can also understand what does it cost, because I have a detailed unit price estimate. There's too many times we've been on projects where a building owner wants to do, say, a passive house or a high performance building, and the estimator says, okay, well, that's going to be 3 or 5% more. Okay, where? Since when does the cost of brick go up because I'm putting insulation behind it? It's stupid. But yet this is what we do because of fear pricing and just not experienced at doing this. To do it right, you guys need a detailed control estimate that you can go in granularly and look at those things that we're changing to create the high performance side of this building. This is an example of what you can expect to see for the entire line item package. So this brings us to our next polling question, our final polling question. And it says, does the building you spend the most time in have a building performance dashboard? So the last question focused around organizationally, do you understand what the client you're working for, your owners, or goals are? This is around your building, the building you're in right now. Do you know what your CO2 levels are in that building? Do you know what your energy performance is in that building? This is really important because it gets to use. There is a major use factor in a building that contributes to how buildings perform. You know, we can build passive house buildings all day long, but if I leave all my windows open and I reset all my stats to 24/7 in lieu of, 8 to 5, if it's a commercial office building, now all of a sudden I've got a problem on my hands. So educating occupants in the type of building they're in is super important. We're just interested to see how many people in the audience have a building performance dashboard. So Michael, feel free to jump in whenever you have those results.
Okay, so the responses here are most 88% don't, none that they know of. 7% yes, but I've never seen it. 5% yes, and I've seen it.
Okay, so that's where you would, start with getting a baseline or some type of way to visualize your existing performance. Even if it's energy consumption at a kind of macro level, putting that in a format that you can have conversations over and talk with the people coming into your building who are potentially going to help you change out one of your major systems that's at life cycle. You want to have this data because it will inform your conversations around future performance. So knowing where you are today is always the first step.
Totally agree. Thank you, Beth. So in terms of building performance dashboards, we offer this as sort of a gauge, right? So how do we get feedback from our buildings? It could be manual. You can get a report on a weekly basis or a periodic basis. It could be a dashboard, a static monitor on a building. When you walk in the front door, you look up and see it. It could be a website. It could be a smart app on your iPad or iPhone. It could be any number of different things to give the feedback to the occupants that's necessary. So for our purposes, if we're investing into a whole building energy model that we want to calibrate and use for the life of the building, then that model can export dynamically simulations. So let's say we go into a project and we set a goal of a 30 kBTU per square foot per year, a low energy performance for a site EUI, right? When we set that goal, that's a static goal annually. Well, would it be beneficial for anyone on the audience to see this dashboard with the static line cutting across all the trends? And the answer is no. It doesn't tell me anything, because are we in the summer or the winter or what's going on? Buildings perform this way. So we want to be able to export the data from our energy model in the same time interval as the trend of data off of the meters and sensors. The technology exists today in both modeling and smart building infrastructure to do this for all forms of energy, including water, and all in terms of indoor air quality, we can do this for temperature, humidity, and CO2. And there's an argument to be made that VOC and particulate matter are mitigated through ventilation for the most part. So now all of a sudden, if we deal with it like a plume, we could run a CFD analysis in the energy model and start to figure out how long it's to take to dissipate the plume. So now all of a sudden you're opening up the door to simulation around multiple parameters of indoor air quality. That's where the macro trends in the industry are going. And right now, this is what you can expect to see on a dashboard. If you look at the two bars to the far left, the buildings are underperforming the simulation. So there should be a notification, an email, something's going on. Take a look at it. Is this a trend or just a single event? Then when we're performing in alignment, we also, again, want to know that. But you're seeing through this one dashboard right here that there's multiple months that we're underperforming. And again, those small interventions pay off in the long run. And it informs the project management, the facility management team on what to look for. And I think that's extremely important when we talk about feedback loops. So we have a case study to present. This project is the East Liberty Presbyterian Church. It was built about 85 years ago. It takes up a full city block in the city of Pittsburgh. It's 7 stories, about 170,000 square feet. It has a full gymnasium for a basketball court, and it has a bowling alley in there. It's a big cathedral. Obviously, we don't have the opportunity to address the building envelope. It's limestone, and for the most part, the windows are stained glass. So our intervention in this building was limited, but it wasn't non-existent. So when we started the project, the whole project team went through an iteration a few times where people were in their silos talking about mechanical systems and talking about windows, but we were having difficulty on how to think about the building holistically. So what we ended up doing is we created ourselves an owner project requirements. So we baselined our energy. We talked about using the 2030 challenge as our gauge, meeting year 2030, which meant about a 35% reduction in energy use, and then increasing our indoor air quality levels in this building to meet the highest performance standards that exist today. And those are reset air high performance standards. Once we went about doing this within an OPR, then we kind of had an alignment with the project team. We all said, okay, we know where we want to go. What can we do to get there? Well, we started by creating an energy model for this building, and that was no small feat, but it can be done, and it was done, and it was very beneficial to us. Then we started asking questions. Okay, well, we got a lot of broken windows. These things haven't been gasketed for a long time. What if we fix all the windows, we gasketed them? What if we close up all the holes in the building? There are a lot of holes around the roofing systems in the attics and stuff like that. What if we went and we put glass doors in front of all the major doors, so we were able to tighten the building up? And then once we got into the model deep and we started figuring out, this building thought that they had a cooling problem. The summertime gets very hot, can't use the cathedral, the sanctuary, and we got to go into the garth outside and have our services out there. And what we discovered is they don't have a cooling problem, they have a heating problem. This building literally turns on in September, full blast, and it goes until about May. There's no building setback, there's no zone control, there's no clock, there's nothing. So we said, what if we were able to manage our heating in this building in a way that had everything we want from controls, take that efficiency, put that in point of cooling for critical areas like rooms, classrooms, offices, conference rooms that are heavily used, sanctuary on Sundays. So we were able to develop a whole plan around how, rather than going in there and cooling this entire building, which was not cost effective or efficient, what if we dealt with just those areas that we needed to deal with? what happened is, we ended up shrinking that whole out of use time to about 5 or 6 weeks. And now we can mitigate that further by putting interventions in there for when it's at peak. So there was a lot of great things that came out of this building. There is a case study on the World Green Building Council for this, and it's the first cathedral in the world to receive Reset Air certification. So if we can do this here, then you can do it anywhere. This is their dashboard. They're able to display not just simulation and trends from meters and sensors, but also invoices. And we can track that now throughout the entire project. They can do this for electric, gas, and water, which are their forms of energy and water. And they can do this for all forms of air quality as defined by Reset Air, which are 6.
So today we covered the foundational elements of best practices, building science, and smart building infrastructure. As we said earlier, the power of existing buildings covers the rest of the map for unlocking the value inherent in existing buildings. So we probably touched on key principles of maybe about a third of our book. But what's so powerful is that when you do unlock the environmental, financial, and social power of existing buildings, nobody loses. Occupants benefit, owners benefit, governments benefit of any size, municipalities, city government, state government, and the planet itself wins. Everyone wins. It's very rare to find something that we can do that aligns everybody's interests and nobody loses. The concept is also evident in the UN Sustainable Development Goals. So what you might find interesting is that when we were putting the book together, our initial working title literally was "Can Existing Buildings Save the World?" And as we started out, it was a little too provocative to bring people to the book. So we really kind of left the last chapter to pull everything together from a sustainable development standpoint to say, these are the threads that weave the sustainable development goals that relate to the built environment. These are the threads that weave them all together, reducing fuel poverty, improving health, and combating climate change. And so we have the tools today is probably, one of the messages we like to leave behind, irrespective of who we're talking to. We have the tools today to look at every project based on those benefits. And then very quickly, I just wanted to spend a couple of seconds on COVID-19 and, in the built environment, and when we have buildings, how can we prevent the spread of viruses and diseases in those buildings? And the short answer to that is controlling indoor environmental quality. When you control the indoor environmental quality by controlling elements of your building in terms of the passive and active systems of a building, you begin to be able to affect the spread of viruses and diseases. Fitwell is the building standard that the Center for Active Design out of New York put together, and they did a really great piece just a couple of weeks ago, and I've put the link there for you. It's really worth the read. It's short, but it's just packed full of research that they found to focus on to make it really clear what would be most meaningful to tackle. So the performance standards, too, additive to Fitwell, that are worth understanding for anybody who owns a building and is thinking about any kind of renovation, are Passive House and Reset Air. Those are 2 standards that really focus on controlling your environment to delivering results in performance and operations. So thank you for your time today. Hopefully you learned something unique that piques your interest to know more. Maybe a technology like digital twinning, maybe a standard like Reset Air, and maybe just how to integrate continuous estimating into a project. We hope so, because owners of existing buildings, all of us, need to be very clear and very committed to the idea that the hill is absolutely worth the climb. So Michael, we are ready for any questions if you have any.
Don't forget about Superman.
Okay, thank you very much, Beth and Craig. We've been getting a number of questions here today, and we'll just remind everybody that you can continue to submit them during the question and answer session by using the questions tool in the control panel, and we'll go to about 2:30. And I will say a couple observations here already. and this is mainly to the audience. Appreciate everybody being with us today. I understand that a number of folks may be more general planners, and some of the language that we're using today highly technical relative to the building industry, but appreciate everybody being here today as well. So I'm just going to dive in because we've gotten many already, and in fact, a number of just popping in right now. So we'll start here with the question, have you worked with buildings pursuing the Federal Historic Preservation Tax Incentives Program, which requires meeting the Secretary of the Interior standards for rehabilitation? If so, did you find that the requirement to meet this standard affected your overall energy modeling, either negatively or positively?
So yeah, we have. Passive house is one of the standards we'll use when we model to do an inside out retrofit, dealing with the insulation barriers on the inside of the wall as opposed to the outside. That East Liberty Presbyterian Church is an example project of that it has historical values that we could not do intervention from. So, coming up against historical buildings is quite common, and how we deal with them is a little bit different. So when you think about really what's happening in Europe right now is they're doing an outside-in retrofit for a lot of their buildings and the facades. They're just refacading buildings. And they're doing it because they see the value to energy efficiency. They see the value to occupant benefit. The United States, we love our bricks and we love our facades, and we're not as far along as Europe is in that regard, but that doesn't mean that the answer is zero. There is tons of research around historical buildings and retrofitting those to high performance building standards. So yeah, this is quite common in our industry.
And part of why we do what we do is, and the modeling is central to it, is to understand what a building's capable of achieving. And sometimes the historical designations impose some sort of restriction. But we can take that into consideration when we build the model and we simulate. We just define those as constraints. And so part of the benefit of technology is you can very quickly rule things in that you can touch and what you can adjust, and then the things that you can't. So a lot of times the modeling plays a real advantage to not sending teams down a hole to try and do things that just aren't possible or achievable.
Okay. Thank you. Next question is, do you see a trend toward merging site sustainability goals with building sustainability goals, such as green infrastructure, outdoor social spaces, and so on?
Yeah, absolutely. So a lot of the standards today are community-based, living community, well community, fit well even on its own, has a lot of overlapping goals when it comes to site and buildings. And part of I think the way people are thinking going forward is all around wellness and what constitutes wellness. And that practice is changing so quickly, it's almost impossible to keep up with. So those are the standards that we would look to as being kind of expert in where those overlaps are.
The only thing I would add to that, Beth, that's exactly what I was thinking, is that when you think about measurement verification, meters and sensors for, stormwater management and things like that apply because it's the same platform. And also how we deal with stormwater. I mean, putting stormwater into a pipe and pushing it into a wastewater treatment plant doesn't make sense. And sometimes we can't daylight. So can we reuse that, using concepts like living building challenge and restoring that and saying, how can I use stormwater to do irrigation? Can I use stormwater to do brown water in my buildings for drains? There aren't a lot of municipalities that are yet permitting stormwater to be used for potable because, you have to go through a whole treatment thing for that. But we're seeing it in Pittsburgh right now, where there's a lot of buildings that are pursuing living building challenge and trying to implement that. So there's a relationship certainly between the building and its site and how we manage those things. And it just comes down to goals. Do we want to activate the environment outside, activate our roofs? That's biophilic. Do we want to access trails and walking spots? That's it gets into a lot of health and welfare types, things like that. So they're related for sure.
Okay, thanks, Greg. Here's a question. How have you seen this approach working on government projects where budgets are very tight and design teams are not necessarily following through the project through construction?
Yeah, that's a great question. So the best way to answer this is the city of Pittsburgh has passed legislation that all of their city-owned buildings now have to be zero energy. In the legislation, they didn't define how, but naturally they're falling on passive house standards for Enterfit. So we've been engaged with those guys to come in and start looking at their buildings, and they re-roof probably 10 buildings a year out of their 210 or 220 buildings they have. So they were starting to say, okay, well, we have to do Enterfit and we're roofing anyway, so why don't we just make this an R50? And we said, well, you might not need an R50. Let's use a model to kind of tell us what those numbers are. So we came on the first project with them. We were able to back that 50 down to an R35 because of the way we were able to balance the envelope for them. And then they're able to do it in phases. So think about this. If you're not familiar with passive house, and we talk about that a lot, it's just the right strategy for how you get low. It's a natural order of sustainability. Passive first, active second, renewables last. If I deal with the envelope first, my loads are smaller. Then I decouple my systems. I heat and cool with one system and I ventilate with another, because then I can do heat recover, and the systems that do that are highly efficient. The point I'm trying to make is that when you look at those different standards, like an Enterfit standard, for example, you create a model, you understand what your low energy solution on the building is, and you wait for your triggers, right? That's our advocacy. Why overspend the money? So now all of a sudden my roof fails and I need to re-roof. Now I know what to do. I'm going to re-roof my roof with an R35, and I'm going to put an air barrier that's eventually going to be connected to other places. Now all of a sudden we can start to plan for that. You have to be careful though with sequences, right? We can do triggers, but then there's sequences. Triggers is, I don't want to replace in kind, I want to make it better. Sequences, I don't want to replace my HVAC system with a low load HVAC system before my walls, because now I don't have a right size HVAC system, I have an undersized HVAC system. But again, we could still manipulate and play with a master plan for that building and what its low solution is, to eventually figure out how do I use my triggers as opportunities to create an intervention for that building. So we're very familiar with public entities with limited resources, and sometimes projects get deferred. We get it, but at the same time, we're spending money on deferred maintenance, on life cycle triggers all day long, and we just keep replacing in kind, and that's just not going to get us where we need to go.
So I would add that for anybody who is affiliated with a government organization of any size, a small town all the way to a large metropolitan area, the one thing you should leave from here is that you should set very high goals for what your existing buildings can achieve. The Pennsylvania Housing Finance Agency, so if you Google Pennsylvania Housing Finance Agency, or you go to our website and you look for an article that we wrote using the data that they had developed. They developed data over 3 years of restoring multifamily buildings. And with a little bit of experience, those buildings now, those renovations to passive house standards that Craig was talking about before, which all that means is low energy. You don't have to spend too much time trying to figure that out. Passive house just means low energy. And so they codified passive house as a pathway for their grant programs through the Pennsylvania Housing Finance Agency. And when they did that, they started measuring how those worked out in terms of costs. And by the 3rd year, the costs of the passive house developments were, or the passive house projects were lower than the cost of traditional projects. So you should leave this presentation feeling like you should set some very high expectations in terms of performance for your projects going forward, and you should not have to pay a premium to get that type of work. So that's a little bit of information and some evidence that you could put in front of somebody to say, well, Pennsylvania did this and here's what they learned.
Okay. It's another question about housing. I'm curious about how these tools can be scaled for residential properties. For example, masonry row houses are inherently more sustainable in energy because of the shared walls, better insulation, etc. But many homeowners, and more importantly, developers, don't see the embodied energy in this housing typology. How can homeowners benefit from these tools and knowledge?
So that's an educational process. I would suggest strongly that if you're looking for a way to educate single family homeowners, there are resources out there that can help them do that. PHIUS is an organization, Passive House Institute US, PHIUS. They do a lot of work in single family and small multifamily. They do have some work in the larger commercials, but these guys are well known for working in the single family and multifamily. And there's a ton of resources on their websites about why. So the argument becomes, do we want to do it just for carbon? That's a hard pitch to homeowners, right? Do we want to do it because it's actually going to give value to the occupant benefit? That's a whole different pitch. We believe strongly that buildings are built to be used, and we shouldn't sacrifice indoor environmental quality or indoor air quality in our buildings, and we shouldn't have to pay a premium to get there. So then the question becomes, if we start talking about healthcare costs, absenteeism, presenteeism, whether or not these buildings are making us sick. I mean, look at the filters when you replace them after 6 months in most homes, and they're pretty bad. There's also this argument around fuel poverty and inclusion for indoor air quality, and the most susceptible group of people in these discussions are always the low-income people, because they're in the poorer neighborhoods and they have poor outdoor air quality, which contributes directly inside. So that's why we think PHFA and what they've done in Pennsylvania to put an incentivization around passive house and tight buildings, high performance buildings for that community is really, really important, because now all of a sudden you're able to put that group of people into a super high performance building, and you're doing it without spending a premium on costs.
But the person who asked that question, laid it up exactly right. I mean, in a lot of cases, these buildings, their bones are right. Their bones are set up properly for this type of renovation. In Europe, if they have some of these 9, 10 row homes or townhomes in a row, they'll do something that's unique to Europe that's just starting to make its way over here, and they'll wrap those buildings from the outside almost in one continuous way. And that's the Eckenrode strategy that Craig was talking about, where they can wrap a long building of multiple units. They wrap that in order to drive improved insulation. So irrespective of whether or not you have a great structure with really terrific bones that would handle more insulation and would handle an improved roof and would lead to really great results, or you don't and it's very porous and you want to wrap the whole thing from the outside, there are technologies in building science today that make that very reasonable, very cost effective to do with reasonable rates of return.
Hey, Beth, I just wanted to add to that one more point too, because the question was built around these common walls, which we refer to as adiabatic. It's a common wall, and therefore it's warm on the other side and it's not an outside wall. That's great. It's a hell of an advantage. We totally agree with that. But when you start talking about high performance buildings, the devil's in the details. Think about it as a water balloon. If I put a poke in a water balloon and water starts coming out of it, then that is my weak spot on the building, right? And too many times we see weak spots on these buildings are the windows, frame, the wall issues, connectivity of wall to foundation, wall to roof, or change in construction materials. If we don't manage that process better, it doesn't matter if I have an adiabatic wall or an R50 wall, because I'm losing all my energy out of this one little detail. So when I said it's an educational process to understand that we have to deal with buildings holistically, we have to mitigate thermal bridges, and we have to eliminate these poor details around connectivity. And if I can do that, then we can take advantage of things like adiabatic walls and other things that are going to work to our advantage.
Okay. Somewhat as a follow-up to that, another question here. My concern is indoor air quality. Everyone likes that new building scent, but the scent is usually due to new carpets and paint, etc. Do you have any list of products that builders can use that are certified and known not to release unhealthy VOCs or other unhealthy particulates, or materials that are less likely to collect harmful particulates in terms of use?
Yeah, absolutely. This is an easy question. So there are two resources I would direct that member of the audience to. The first is go to the International Living Futures Institute's website. That's the Living Building Challenge. Look at their materials pedal. They have a red list. That red list is the list of materials that organization has banned for one reason or another. Either it's lead or it's a harmful hazardous material. And it can be in small quantities, but we have formaldehyde and glues that we buy for our furniture all the time, and it off gases and it's harmful to us. So it's not always about asbestos and lead and mercury. It's about common materials that we see all day long that are still very harmful for VOCs. The second resource I would suggest you go to is go to the International Well Building Institute's website. That's the Well Building, and they have a material concept and their program, and their material concept references 2 other resources, including the Red List. One is out of California. I believe it's a San Francisco list, and there's a third list that's out there. You can email me, and I'm more than happy to share those lists with you, but those resources are readily available. And what's happening now is the whole market has caught up to toxicity of materials, and we're starting to figure out, if you want to know the answer and whether a material is healthy or not, you can get that answer pretty easy. Where the macro trends are heading right now is to embodied energy. And now we're starting to look at embodied energy as a relation to those materials too, because, the greenest building today is the one that's already built. And we didn't coin that phrase. I think Carlos Elefante did out of DC. But it's true. And it's true when you consider it from an embodied energy perspective. We have to figure out how to repurpose our buildings, because we're not going to fix our problems with climate change with renewables or raising all of our buildings that exist.
Okay. Here's a question. Can you talk a little bit more about stretch ordinances?
Yes. So I can. And there's a lot of research around that. So I'm a board member for the North American Passive House Network, and Beth is a special advisor to that group. It's an international organization of passive house practitioners, and we have a whole policy division in what we do. So I'll give you an example. When New York City wanted to change its codes, and they wanted to figure out how to do this better, they started with stretch codes. Stretch codes are voluntary. People come in and opt in for better performance of their buildings. Then they quickly reverted from stretch codes to putting it in the zoning regulations. So if you're in one of the boroughs in New York City and you wanted to get zoning, you had to go to Passive House. And then they went to their Climate Change Act, and their Climate Change Act now is mandatory. And what they said in there is they said that every building over 50,000 square feet in New York City has to reduce consumption by 40% by 2030 and 80% by 2050. So the reason why I'm telling you all this is that there's a process, the way policymakers think about this. It starts with energy disclosure ordinance. It goes to stretch codes. Then it goes to somehow codifying it, and New York did it through zones. Then it goes to legislation. Pittsburgh has adopted that pathway, but the one thing that they changed is they said, well, we got to do it first ourselves. So they went and they changed the code so that all city-owned buildings have to be zero energy. And then once they do that, and then they can demonstrate to the public how to do it. So that's my answer with regard to policy and how you think about it from a timeline.
Okay. Next question here. As you promote the use of simulation in implementing goals, don't you think the cost of the simulation can affect the overall cost of the project?
So I'll start with that, Craig, first. So it kind of depends on the partner that takes that over in your chain. So there aren't necessarily a lot of architects that do that simulation work. There are a fair amount of MEPs that do that. And then there are consulting firms or sustainability or technology firms like us. And so it kind of just depends on, so it's a hard question to ask because it kind of depends on who would step in to do that work. The most important thing as a building owner for you to ask or understand is what happens to that work product when it's done? Who owns it? And if most engineers who would do that work, they tend to own that work product and you get a report. So we would say it does not have to be more expensive. In fact, the way we handle it and the way we look at it as you know, kind of growing with the project and becoming part of the building and being capitalized as part of the building and the construction cost of the building, it's you know, we think probably the best investment you can make to understand your building at a really deep and finite way. You can get you can begin to kind of dial in and tweak performance, and then dial in and tweak the estimating, so that you can get a really tailored renovation of a project by combining the two. So we think it's an incredible investment to make, and we don't think it's expensive. I wish we could give, I don't know, Craig, if we could like point to the size of a building and say it shouldn't cost more than this. But I mean, for, let's say, a smaller building, somebody should be able to do the modeling and simulation work for $5,000 to $10,000. It should not be one of those things that you sit back and you say, oh my God, how am I ever going to afford that? And if you think about it from the standpoint of, now I have an asset, it lives with my building forever and continues to inform any design team that comes onto that project in the future. It informs them on what the building was designed or renovated to be able to do. We think that that returns on itself many, many, many times over the life of the building.
Hey, Beth, the only thing I would add to that is there's not one thing in our presentation that we presented or offered that's not already included in the process of construction. We model projects all the time. We have reasons for modeling them. Maybe we're doing lead support modeling, or we're just sizing equipment. Estimating is done all the time. What we're saying is that we have to think about projects differently. We have to repurpose what we're doing with the information and when we want that information. So while it may feel to some like there's an early investment request because of modeling and maybe some smart building infrastructure, our answer to that is not something you wouldn't have spent anyways. You're going to spend money on a building automation system or a building management system, BAS, BMS. You're going to spend money on modeling. You're going to spend modeling on estimating. Wouldn't I want that information first? And as an owner, wouldn't I want to control that so that I make sure I have access to the granularity of that information and I'm getting the right people to do it? So for our purposes, it's not something that we're not already doing. It's just a different sequence.
Gotcha. Okay, next question. A lot of public projects in Cleveland seem to involve a demolition followed by new construction in pursuit of higher performance LEED status. Should the demolition of an existing building be added to a new building's carbon footprint to get a fuller picture of fossil fuels already used in the construction of the demolished building? It seems the sustainable status of the building should account for what has been sacrificed for that status.
I totally agree. Yeah, that's the embodied energy conversation. So we have operational carbon and we have legacy carbon, right? The building carbon. And we believe totally that we cannot ignore that. And it's something that we're going to pay for dearly if we get too far down the line without addressing it. The concept of raising a building to build a new LEED Platinum building is like an oxymoron. It doesn't make sense at all in any way, shape, or form. It's not even logical. So, you know, why not repurpose that building? And a lot of the programs that we talked about, the sustainable certification programs, talk about that, but they don't give it enough weight, and they weight other things differently. And again, gets back to goals. You know, if you are the person, the planner for the city of Cleveland, you know, do you want to see them raise every single building and build brand new buildings everywhere? I mean, it's great you got your brand new shiny object. If it's built right, you might have a great performing building, but we're not going to raise our way to fixing climate change. And not only that, think about all the carbon that goes into that new building that we're going to build right next to that existing building was there. So the answer to this paradox that's presented is really in the form of carbon.
Yeah, and adding to that, we almost need to make it, you know, all things being equal, we need to make it socially unacceptable to bring the building down and build new. It's almost an emotional or attitudinal issue once you equilibrate the math. And what we're saying is approaching it the right way and approaching a building holistically. All things being equal, you should be able to build the high performance building or renovate a high performance building out of an existing building for the same cost as you would to tear it down and rebuild. So once you equilibrate that, now it's attitudinal. And so we have to fall back on all of these other motives, the environmental motive, the financial motive, the social motive. We have to fall back now on those motives to say, it's just not right. The place we probably see this the most is when, you know, K through 12 school superintendents look to build new or you know, renovate existing. And most every project team that walks into that superintendent's office says, you know, if all things being equal, we're not going to be able to, you know, renovate this for any less expensively than we could build new. So all things being equal, you should build new. And that just seems to be the accepted point of view. We want to kind of flip that on its head and say, no, 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 for the purposes of the planet and everything else that we can do with that existing building, we think we're going to renovate.
Okay, so I guess in line with that, is there a type of tipping point where an existing abandoned building is not worth retrofitting? I.e., it is better to demolish and start over.
Yeah. Yeah, there is. I mean, unfortunately, there is. And it's, if the building has been ignored long enough, and we're experiencing this right now on a new high school that we've been called in to help them with, is that the facades have been ignored for so long, the roof has been leaking for so long that all the facades basically are, you know, the mortar on the brick is all dust. You know, you take a brick off and it just deteriorates. If the structural steel, if it's a, you know, red iron building, if that's all rusted out, I mean, then you simply can't do it. But I don't think it necessitates us giving up on the entire conversation, right? You know, there are times where you have an existing building that simply just needs to be, you know, removed or raised and then rebuilt. But does that mean the whole thing has to be done? Do we have to change the entire site? Is there a way we can preserve some of that historical context and reuse it? So, or, you know, can we use some of the materials? I mean, if we have to raise that building, can I retain the brick? Because if the mortar's already sand, can I keep the brick and reuse the brick? Now I've got a reused material. So again, it gets back to that carbon, the embodied carbon conversation, and figuring out how much carbon is in that building, how much can I repurpose, how much can I redirect from landfills. So it's part of the same conversation for sure. And this gets back to goal setting, right? So if we're going to set goals around embodied carbon, then those decisions become very more prioritized. They become more prioritized.
Okay. Is it possible to renovate an existing building for disaster resilience and sustainability using this model?
New Orleans. So when New Orleans and Katrina hit, the U.S. Army Corps of Engineers adopted Passive House, and they did it because, you know, they were moving people in New Orleans around a natural event, and moving in the Superdome, people were dying. And, you know, they started to say, is there a better way to do this? Well, that's where Passive House comes in. If you build a Passive House, you have an envelope that is super tight, super insulated. If you have a natural event, the building, the indoor temperature and humidity in that building will take literally about a week or two, depending on its climate location, to change. And when it does change, it changes very slowly. So if you want to talk about resilience, I would strongly suggest that the audience member look up Passive House, focus on why Passive House is the major contributor in resiliency, both from an energy perspective and sanctuary places. And to me, that's the closest evidence I've seen of getting to resilience without artificial means like a generator or other things.
Okay. Do you have some good examples of cities or institutions that systematically evaluate building renewal versus new construction based on performance or these carbon measures?
Probably New York City. You know, they're the most aggressive right now in reviewing renovations for their city buildings, and pretty much demanding that in almost every case that building is renovated to some standard, to zero energy over a certain period of time, but they have to get to certain milestones based on that building. And so that's probably the city in the US that's most aggressive, but there are cities all over the world that have a routine approach to looking at buildings and expecting that buildings be renovated or built new, but in this case, let's just talk about renovations to certain standards like Passive House, where you can be pretty certain of what type of performance you're going to get in operations.
Okay. What type of certification or training would you look for when looking for an outside contractor to perform this modeling? Is there training that we could do to have more formal education on this?
There is. As a passive or the NAPHN board member, we do training all the time. We could do training specifically developed for agencies or firms or organizations. When you're looking for your team, this is what I would refer to as team building, right? when you're looking to build your team, the first thing you need to do is you need to build your RFP that is consistent with demanding these performance measures. If we go out there with a traditional RFP and we onboard our architects and engineers, and then we want to have a passive house or a conversation about high performance buildings, they view that as a change order. Now all of a sudden, as a building owner, I'm upset and frustrated because, you know, they're not giving me what I wanted. But it starts with the RFP. So again, there are ways that we can create and craft an RFP around what do we want to get out of this building. When it goes to the modeler side of this, I would strongly suggest looking for passive house experienced practitioners. You know, if you go to the ASHRAE side of the conversation and you're looking at ASHRAE or LEED or other things, those aren't as powerful as really taking an envelope first approach to this, where passive house will always take an envelope first approach. They're both highly qualified in terms of their credentialing and training for modelers. They understand the metrics and they understand how to use the model, but it's about why we're using that model. Why do we care? I care because I want to take an envelope first approach. That's low energy, that's a natural order sustainability. So I would suggest that when you're looking to do that, focus on team building, get your RFP right, look at the passive house practitioners who are doing that. If you want to do some in-house training, I would strongly suggest either FIAS, Passive House Institute US, has a CPHC program. I'm a CPHC. They have a tradesperson program for contractors. And PHI, Passive House Institute, that's the European standard, that's NAPHN. They have a CPHD program, Certified Passive House Designer. And they also have a tradesperson program. So as you're building the team, just make sure that you have that common thread of performance through the RFP so that the designers don't come back to change orders. And if you're doing it early enough, we haven't experienced the premium in architect services for that at all. I mean, we're putting it in there and they're like, yeah, we've been doing LEED for 10 years. And we're like, okay, here's my metrics, here's my OPR. And when you have that to your benefit, then you shouldn't have to pay a premium for that. Architects claim that they're doing that all the time.
And Craig sounded like he just went through the alphabet twice with all those acronyms, but you know, all of those organizations are on our website. The website was at the back end of the presentation. As you guys look for us, if you're looking for these organizations, just flip to the website and go down to the bottom and you'll see all those organizations and they're all linked. So you can just link to those organizations to learn more and you don't have to deal with the alphabet soup.
Got it. Okay. And we'll include some of the links on our archive page once we post the video. Are you seeing existing school buildings being evaluated using these models as part of the renovation process?
Absolutely, especially the smart ones. We do a lot of work with Green Building Alliance, which is part of the USGBC here in the US. That's kind of our local green building organization, a nonprofit. They do a lot of work with schools, and we provide a lot of support around how to think about renovation versus building new. There are trade-offs, and every school district is going to be dealing with different things. You know, there are a lot of school districts today that immediately reach for energy savings companies, which are affectionately known as ESCOs, because they provide financing. But grabbing that tool too early in the process will only cause the school's agenda to shift to the things that return the highest, like changing out lighting and doing things that provide some more immediate return on investment. The problem with that is that it kind of undermines our natural order sustainability. So we want to first kind of improve the school's passive system and then review the active system and then look for renewables to offset any additional energy after that. If you grab the wrong tool at the wrong time, you don't get that holistic solution. But there are a lot of issues that schools have. So there's no judgment. It's just a matter of, is there a better way to build that mousetrap? And we would say that, you know, working with organizations like what we have, Green Building Alliance, pretty much every city in the country has organizations like that. Tap those organizations to help you find the expertise to be able to make that decision the right way. Should I build new or should I renovate? And considering everything, whether it's energy or carbon or indoor air quality, indoor environmental quality, you want to just get the right thought leadership to have you walk through the process the right way.
Okay, to follow up on that, actually, from our experience here in Maryland, we're looking at the total cost of ownership as one of the metrics as we evaluate new school projects. Is that something that you're looking at all? And how would that fit with some of these other metrics?
Yeah, sure. We do the same thing. I'm not sure if we use all of the same components you do in a total cost of ownership, but the most obvious place where you can get a little bit of dissonance between on decisions and where you might want to think about trade-offs is in first costs and then long-term operating costs. So we look at long-term operating costs in parallel. So when Craig talked about earlier in the presentation, the idea of continuous cost estimating, we're looking at first costs in most of that continuous cost estimating, but because of the way we do our modeling, the modeling and the cost estimate and then the long-term operating costs of operating that building all come into play. So that our idea is that at any point in time, a building owner should be able to ask for exactly that, Michael, like, how does this compare with my long-term cost of ownership? How do I take a decision, a discrete decision, and put it through those filters at the same time to then be able to prioritize how I get my best return?
Okay, thank you. Are these standards something that can be incorporated into a city's zoning laws for building new housing and businesses?
Absolutely. I mean, if you look at the life cycle of energy disclosure ordinance, and we talked a little bit about that when we talked about stretch codes, you know, if you look at like this, Seattle started this long time ago. They started with disclosure ordinance of public buildings, then it went to disclosure ordinance of private buildings over 50,000 square feet. Then it went to disclosure of everything. Then it went to performance, right? So now we want to start ringing that. And if you think about the slide that Beth had shown early on, where we talked about this life cycle of, you know, going from concept or conceptual all the way through prescriptive and then outcome based, this is really what's happening in the terms of policy right now. And how do we start to set these? So there's resources out there to assist the audience member who asked the question around this. I would suggest strongly for, you know, organizations like NEPHN, North American Pass Bus Network, or NESI. Those are East Coast agencies, organizations, nonprofits that would provide assistance to any municipality looking to figure out, how do I start and then how do I eventually get there? Because there's a little bit of you know, political risk for the mayors and governors when they start setting those policies, that they don't want to go too much too early and have everybody kind of have a backlash on them. But right now, you know, New York City just leapfrogged California and Seattle, and right now they have the most rigorous and robust set of goals that are out there with their Climate Change Act. And I can tell you, we were in a room with New York and California and Seattle and Portland, and they were all talking about, okay, how do we do it? And what you're going to see is this compounding effect that's just going to build on each other until everybody gets to performance evaluations, outcome-based criteria.
Gotcha. Okay, we're getting near the end, so I'll just ask a couple more questions and we'll ask for some final remarks. I guess related, are any of these practices worked into any state or international building codes? How can a planner best propose these ideas to applicants that want to expand an existing building or build new?
Yeah, absolutely. Brussels was probably the first European country to codify passive house, and they did it. There's a great story. I've seen their presentation. You can Google Brussels and find it. It's a great story. So about 5 years ago, they almost mistakenly did it, right? They wanted to be aspirational. They knew climate change was a problem, and they set passive houses code. The first year, everybody complained. The second year, the complaints were much, much less. By the third year, it was par. And now by the fourth and fifth year, they're starting to lead the world in terms of equipment, right? So now, you know, getting low flow equipment in the United States is a challenge. Getting passive house windows in the United States used to be a challenge. 5 years ago, you had to buy it from Europe. Today, there's 18 manufacturers in the States right now that do passive house windows. So getting access to air barrier technology, better thermal barrier technologies, windows and low flow equipment and other things like that has always been our challenge in the States, because, you know, energy's been cheap and we don't necessarily care about climate change, generally speaking, for the most part. So we've always been behind Europe and Canada, where they have been going. And Canada's absolutely kicking the crap out of the United States right now in terms of efficiency. So yeah, there's a lot. I think Passive House Canada, Rob Bernhardt, the CEO of Passive House Canada, is a great example of how to scale that. He's done that literally from Vancouver to Toronto, Montreal. And right now they're getting funded to the tunes of hundreds of millions of dollars to train, to implement, to do the certifications for people and buildings. We're starting to see that same trajectory in the States, not as quickly as Canada did it with Rob. But you have Canada as an example, Brussels, Germany. I mean, there's a reason why Germany leads the world in PV. It's not because of access to sunlight. It's because the Passive House Institute was founded in Darmstadt in Germany, and they have the most low energy buildings, and PV at that scale is affordable. It's deployable. When it breaks, it's affordable to replace, and they lead the world in photovoltaics. And there's a reason for that. So we're starting to catch up. We're seeing a lot of great macro trends, but we're nowhere near what Europe and Canada are doing right now in terms of this discussion.
Great, thank you, Craig. So with that, I know we're getting to 2:30 Eastern. I think we'll go ahead and wrap up here, and appreciate all the questions that came in. We were not able to get to all of them. We will be posting the presentation on the archive page with the recording of it once it's ready. But I'll just, I guess, close today by asking both of you if you have any final thoughts based on what we talked about today.
Sure. So I think given what we learned, especially through some of the polling questions, we would encourage all of you, irrespective of the role that you have in whatever organization that exists to drive building performance, baseline your building. Understand what your energy performance is and the most important parameters of indoor air quality: temperature, humidity, CO2, particulate matter. Know what your buildings are doing today. And then as you take on any project, and you don't have to try to boil the ocean, take it one step at a time. But as you do, require that nobody does anything that's going to harm those numbers. Like, you don't want it to go the wrong direction. So establish those as requirements. Like, you have to do it, you have to, whatever you're going to do and come in here and replace, you can't make our energy performance or our indoor air quality any worse. So start there. And then as you set higher goals, then build your teams so that you get some of the capabilities that Craig was talking about, and know going into all of it that it doesn't have to cost $1 more to build a high performing building than to build a traditional building. And that's been proven now enough here in the United States with different organizations like Pennsylvania Housing Finance Agency to groups over in Europe. So we know those things to be true. Existing buildings have tremendous power, and it's up to us to figure out how to unleash that power. We do a presentation with a woman who likes to call existing buildings Superman. And basically what she says is it's Superman who's looking for the telephone booth. And so what we're trying to do is put some structure around what the telephone booth looks like and how you can possibly get there to really unleash some power and drive those environmental, financial, and social motives.
That was great, Beth. Thank you. The only thing I can add to that is that, you know, while it's easy to grasp onto energy and carbon as policymakers and people in those kind of positions, let's try not to lose focus on the value in what we do in existing buildings. And 90% of that value is built around occupant benefit. So when we think about buildings, think about who's in them, what are we using them for, and how are we providing the best environmental conditions for the people in that building. And then do we have a feedback loop to make sure or ensure that we're getting what we paid for? So I totally agree with everything that Beth said, but I can tell you that in our early days of doing what we do, we figured out very, very quickly that all the money's in the people. And that educational process of educating the people who own those buildings and the companies that employ those people in those buildings, that's where all the value's at, that's where all the money's at. So thank you everyone very much for joining us today. We are excited to present to you, and we had a lot of fun.
Great, thank you both, Craig and Beth. This will conclude our webinar today, Unleashing the Economic and Sustainability Power of Existing Buildings. I'd like to offer a big thank you to Beth and to Craig for a great presentation, and to all of those who attended, and also to John Coleman, our communications and technology guru, who works behind the scenes to help make this all happen, especially now that we're all working remotely. The complete recording of today's webinar will be posted on smartgrowth.org in the next couple days. Also, all attendees will receive an email tomorrow that will contain a link to a personalized certificate of participation please look for this follow-up email. When you exit from today's webinar, you'll be asked to participate in a short evaluation. Please take a few moments to provide feedback so that we can continue to improve the webinar experience for you. Keep an eye out on smartgrowth.org and our e-newsletter for details on other future webinars. We are endeavoring to provide you with planning webinars during this period of teleworking for many. So if you have a topic, panel, or suggestion, please include it in your evaluation or email me at michael.bayer1@maryland.gov. Finally, please join us for two upcoming webinars. Ilana Prus of Recast City rejoins us next Tuesday, April 21st for The Front of the Line is Not Inclusive, Why We Need to Better Prepare and to Save Our Small Businesses. And Peter Plastrick will be here on Tuesday, April 28th, for Life After Carbon, the Next Global Transformation of Cities. Visit smartgrowth.org for more information on these events or to watch for our future email blasts. Have a great day.